morning, everyone, or afternoon or evening, depending on where you're coming from. Welcome to the SEG Near Surface Geophysics Technical Section Student Subcommittee webinar on ResIPy. This is part of our webinar series on open source software. This is our fourth installment. My name is Chris Terra. I'm going to be your kind of the moderator for today, and our speaker today is Sina Sanayan. Sina, old time at Rutgers. I've never actually asked how to pronounce your last name. Was that even remotely close?
That was good, yeah.
Okay. So Sina is a geophysicist whose research mainly focuses on near-surface environmental and engineering problems. Sina has been an active member of SEG since 2015 and is currently an assistant professor of environmental geophysics at the School of Geosciences at the University of Oklahoma. He holds a bachelor's in mining engineering from the University of Tehran, a master's in petroleum engineering from Sharud University of Technology, and a PhD in environmental sciences from Rutgers University in Newark. His postdoc research was on the assessment of soil deformation and failure with complex electrical methods. Sina's current research builds upon his initial goal of bridging geophysics and engineering. Sina is aiming to show that geophysical methods can be used as reliable characterization tools for monitoring natural hazards, and potentially can be used as effective geohazard prediction tools in the future. Sina is an experienced geophysicist and knows a wide range of geophysical techniques. He has research experience from a small laboratory to surveying Lake Michigan. He also is a skilled programmer. Sina is a core developer of ResIPy, which is a 2D and 3D modeling and inversion code of geological data, SciPy Studio, which is a 1D spectral induced polarization data analysis tool, and has contributed to developing eMagpie, which is a modeling and inversion software for electromagnetic data. Aside from work, Sina loves hiking and is an avid cyclist with thousands of miles ridden on his bike, Red. Over the course of this webinar, if you have any questions, any comments that you want addressed at any point, feel free to throw them into the Q&A section, and they'll be kind of addressed as, once we get into the actual Q&A period. Before we begin, there will be a short presentation to kind of start things off. The expectation is that the software of ResIPy has been downloaded for everyone. So Lori will supply some instructions based off of your operating system for how to easily download and access it. So make sure between now and the time we start getting into these hands-on exercises that you have ResIPy downloaded and ready to go. I think that's it as far as opening stuff. Sina, do you want to take it away?
Thank you very much, Chris, for the great introduction. So I'm going to share a few slides and then jump into the actual software immediately. So let me just first of all, I wanted to thank the co-authors of this software, my colleagues Guillaume Blanchi, Jimmy Boyd, Paul McLachlan, and of course Andy Binley, who actually is the developer, the inversion code behind this software. We came up with this idea in 2018 when Andy was into creating this, writing this book about near-surface geophysics, electrical methods particularly, and we thought it would be great if we could supply the book with a software that is intuitive and easy to use for everyone. And we did not expect that to be something more than just additional information to the book, but now ResIPy has been a well-known software. It's been downloaded more than 10,000 times. It's been cited, the papers that we have, more than 90 times, and we have more than 12,000 individual project reads on ResearchGate and more than 200 followers, and this is quite a it was quite unexpected for us to have such a huge turnout for this specific software. So it actually made us to go and improve it, and just being a simple inversion software that you click some buttons, now it is an intuitive software that not only does the simple inversion, but also it does modeling, it does data processing, it does full 3D forward modeling with the GUI, graphical user interface. And in our opinion, probably a lot of people who have used a bunch of other software and maybe other code, probably they realize that it's much easier to work with compared to just coding platform. And initially, we realized that the biggest problem is that everybody needs to be a programmer to be able to run most of the current available open source codes out there. So the whole idea behind this ResIPy or ResIPy, whatever you want to pronounce it, really doesn't matter, is that to make it easy and accessible for everybody to work with this software. So it is, if I want to put it in a very summarized graph in here, ResIPy does inversion, meaning that you feed it the data and get a model, and also does modeling, meaning that forward modeling, basically you want to get data out of a model that you have. It does both of these in a single package that you don't need to install it in your computer. All you have to is just download it and run it. Basically, the workflow for inversion includes importing the data. We include a lot of different import data types that I will explain later on as we move forward. It does a lot of filtering and data processing, basically, how you want to filter the unwanted data out of your data. It has a very powerful error analysis if you supply it with the right data, which again, I'm going to talk about. It does the meshing for you, so you don't have to create a mesh and feed the mesh separately, although you can do that. And then there is a bunch of settings there that will make the inversion for you to go even smoother as expected. And then you create your model based on your data. And then at the other end, doing a forward model, you have a hypothesis. Let's say you have a multi-layer structure in the subsurface. There is groundwater at some point. You basically create your model in a mesh that you have, 2D or 3D, doesn't matter. And then design an array to, assuming that you're going to field and do that survey, and then basically define some errors, uncertainty errors, and then you create your data. And then you can compare that and kind of optimize the array for an actual survey that you go into the field and doing that. ResIPy is based on Python 3. We made this as a separate application programming interface and the graphical user interface setting, meaning that if you are a programmer and comfortable with programming, you don't need to use the GUI, and the API actually provides you with a lot more details and a lot more capabilities to work with. But nonetheless, if you're not comfortable programming, you have almost 90% of all that capabilities in the programming interface into the GUI. There are some small details that are hard to work with the GUI that are only exclusively available to the API, but you get a lot of details in the GUI already. It's an object-oriented workflow, so if you are not a programmer, but you want just to try the API, you still can do that. It is not super hard. You don't need to start coding from the scratch. There are some specific functions and commands that you use, and then you just feed the data similar to the GUI. Instead of pushing a button, you write like import something, and that works easily as well. So I'm assuming that everybody already has the software up and running currently on their system. So I just want to go and show you how to work with this. So starting from a simple 2D inversion setting without changing any settings, all the way to the very sophisticated modeling in 3D, for example. So before I do that, is there any questions? I don't see any questions in the Q&A. Okay.
Right.
All right. So once you open it, it should look like this, right? If you're using a Linux or Mac, it may take a Linux or Windows. It may take a while to just unzip the whole package, just like what it took for me right now to run the software. To basically not to spend that much time, you can actually go to our GitLab page and download the zipped version of these, except the Mac. So the zip version allows you to open the file directly without the loading and unzipping. But then it is not one single package, it's a bunch of files, and maybe it's slightly more complicated than it should be. Okay, so when you open it, you're like that, seeing a GUI that has a bunch of tabs enabled. So importing data tab or enable, you have the custom parser tab enabled. I'm going to talk about that later. You have the help tab and the about tab open. The rest are like inactive. They are like grayed out, meaning that they are not available for you to work with. That is because you have to first define something. Either you have to say, I am doing a forward model or I'm doing an inversion. So let's say for now, the default is inverse and the default is a 2D project. We're going to go with that and then slowly explain which one is what. At the top, you have the selection of 2D or 3D. If you have a 3D problem, you just click on that. This box in here turns a different color because it's about to show a 3D graph. You can title your survey. This is not really important, but it's up to you if you want to do that for later use. When you load your data, for instance, you can give it a date. And then at the bottom, you have the forward and inverse and other capabilities, like a time-lapse survey, if you have a bunch of files that you want to invert them at the same time. And if it's an unconventional survey, it's just basically tell you that don't show the pseudo section for me. We're going to talk about that. And then pseudo 3. What I always tell everybody to do is to change the working directory. Currently, it is somewhere hidden in your temporary folder in your Windows, Mac, or Linux. So it's best to just change that to somewhere that you know, so you have all your files there for yourself. So I'm going to open that, and in desktop, just create a new folder, call it 2D inversion, and select that. And then you can select the file format that you have. All right, everybody's seeing everything better now?
It looks better.
It does, yep.
I just made it smaller. Okay, sorry about that. Okay, where were I? Where was I? 2D inversion, select the folder. Then you get to the file format. All right, so it's a drop-down menu. By default, it's called Protocol DC. This is the default format that is working with Andy Bilney's codes, R2, CR2, R3D, and CR3D. But you have other stuff as well, like if you're using a Iris instrument, Syscal stuff, instruments, you can use that. I know a lot of people are using Res2D or Res3D Inv file formats from their previous surveys. You can select that. Prime is for certain British Geological Survey instruments, Sting, ABEM, Litman, Aries. And if you have other codes such as PyGimli, BERT, or E4D, you can also import that. And at the end, you have the custom format, meaning that it doesn't follow anything. Then you can click on that and it brings you to this custom parser tab. This custom parser allows you to import any data that is not following any of these formats that we just talked about in here, and then you just basically import your own data. There are some limitations to the custom parser, but we will talk about that later. So for now, let's start with maybe some of the help that you have. and how to basically submit an issue on GitLab. I think that's the most important part. So for the help tab, if you go to the help tab, the general help is pretty quick to read, and it gives you a lot of details to how to work with ResIPy. But if you need more than that, there are links to our YouTube channel, as well as documentations of and examples that are already run with this. And also, I suggest that whoever is interested in more detail about the inversion behind the scheme behind the whole software, to read the manuals of R2, R3T, and so on. These are just PDFs, so just click on them, they're going to load. Okay, and then submitting an issue, I think I have to share again my whole screen, so I will do that and then go back to that part. Okay, so when you have a question or something that is bothering you, there is a bug, hopefully you found the bug, you go to our GitLab page and just basically go to the issues tab. You have to have an account and then submit your issue there by just creating a new issue. And then there are several things for the issue that I have to mention, that we must be able to reproduce the issue. So if that issue requires a certain file, it's good to share it with us. You can make if you don't want that file to be shared with everybody, you can make this issue as a confidential issue. Therefore, it's just the project owners, it would be me, Guillaume, Jimmy, and Paul, who will see that. And then you have to be as detailed as possible with the error and everything for the submitting an issue to be able for us to solve it for you. And if you have any questions, also, don't hesitate to ask in here. It says issues tab, but you can have any question that you might think is good to be answered by a professional. You can ask us in here. All right. Going back to ResIPy. All right. Now it's working.
All right.
Okay, so let's start with with a simple 2D inversion from Res2D, that I think a lot of people have this file format and it's kind of popular, so we'll do that. So I'm going to file format, selecting Res2 3D and then I'm clicking on the import data. By default, it will take you to the example folder that we already supplied with the software, so you get all of these different possibilities to just test the code. So in there, if you go to the parser folder or directory, then you will have some files that are in Res2D format. I'm going to select Res2D -dd. That's a dipole selection. I will open that. So now in here, you will see a pseudo section of the pattern resistivity distribution. You can contour this and just look at it as a contour format. You can select a minimum and maximum of the pattern resistivity that you want to show in here. So let's say I want to show a minimum of 550 and a maximum of 1000. And apply. So it will show me that only. And then you can actually do a lot of other things with it in here. You can zoom, right? Obviously. So for zooming in, you just use your left click. For zooming out, you use right click of your mouse and you zoom out. Okay. You can save this figure in its current state. So all of this white thing that says in here, you can just click on that and save it as a PNG or other formats available, just that specific image. You also have the ability to basically edit most of the plot if you like the axis. If you click on this kind of, let's say, arrow thingy. So let's say I want this to show the y-axis to start from 15. I will do that 15, right? And then apply. So that shows me from 15. Okay, so why did I import this res2dn file? Well, it was a file that was supplied with a topography already. Okay, so when you import a file, the next thing that you have to do is, most of the time when you do a survey, is to look for the topography, right? This is a 2D file and already has topography in it. For those of you who have worked with res2dn files, you know that there are two ways to add the topography, either at the end of the file or implemented inside the general array format. If it's there, ResIPy will automatically read it for you. But if it's not there for some reason and you want to import it, you can basically import it in here for each electrode that you like. Additionally, if you have missing any topography, let's say this is gone, and I have no idea what that is, you can just use the interpolate missing topography, and it actually interpolates it from the linearly from the points before and after. So you can clearly, you can easily just do a few electrode topography and then interpolate rest if you don't want it to exactly do the topography for each individual electrode. Let's say you have like 100 or something. If you have additional topography points, meaning that they are not electrode topography, like any point in your survey, you can use the bottom table in here, adding a additional topography points. So let's say my electrode, the first electrode has 0 meter, the second one is 3 meters. So I want to add a topography at 1.5 meter, 1.5. And then I will make that one 100, 178. Or 180 actually, something weird, so we could see it in the when we do the meshing. All right, so this is an additional topography point that is not related to the electrodes. All right, so this file now is ready to be meshed and inverted. So I'm going to the mesh tab. We'll talk about pre-processing later when we have a data that includes more error editing capabilities. Okay. If you go to the mesh tab, now for a 2D problem, you have a quadrilateral mesh that you can create and a unstructured triangular mesh. Quadrilateral mesh is easy to create because it doesn't really, it doesn't call as secondary software to do that for us. That is included with the ResIPy. So you, therefore the processing is quick. So you click on it, you get a the mesh that you want. And if you look here closely, if I zoom in, you see that this is the extra point that I added. That is between these first and the second electrode. All right. And every time that you want to reset everything to the initial state for any graph in 2D, you just click on the home button. All right, so I created this now for a quadrilateral mesh. You can make the mesh elements finer by taking this to this slider to the higher numbers, and then I create something that is even finer, so it's really hard to see it now, but if I zoom in, you can clearly see that. Or you can make it coarser, depending on what exactly you want to do. For the triangular mesh, you have some additional settings. So the characteristic length in here is basically the individual. I'm creating a mesh to just tell you what that is. It is the at the surface between each two electrodes, there are several elements, right? These triangles. The characteristic length is the length of this triangle at the surface, the side that is at the surface. So if you want to make a coarser mesh, you increase this one, and then this will be increased. So if I create now a triangular mesh, and you can clearly see now you have 2 elements between the electrodes, while before you had about 3. right? The growth factor is telling you how the elements from the surface all the way to the bottom of the mesh will grow. This is, as you know, the uncertainty increases as we go deeper and deeper. Therefore, we're going to add big, larger mesh elements in there because of the that issue. But it's up to you. If you want to have a, I don't know, a lower growth factor, you just decrease that, create your mesh, and now you can see that the elements are growing at a slower rate when you go deeper and deeper. And you can refine that as well. If you select the refinement in here, it actually divides each element into 2. So now everything is like divided into 2. This is one of the things that with the API you can control better. So in here, you can just refine once, but in the API, you can refine as many times as you like. You can divide the cells into 1,000 cells, up to you. The benefit of refinement in comparison to do just changing the characteristic length and the growth factor is that it doesn't change the shape of the mesh at each individual cell at its initial state. Okay, so we're going to create a coarse mesh now with a large growth factor because I want this to go fast. All right. Another thing that is really good in here, it is the fine coarse boundary depth. This is defining how deep you want to see. We put this in here for when by default, ResIPy looks for the longest dipole you have, so the longest distance between the measurement electrodes, not the longest distance between the 2 electrodes. So let's say the 4 electrode combination is there. The largest you have, like, I don't know, whatever, 10 meters or something. And then we divide that by 3. So that's how deep we look. But sometimes that might be not enough for you. So what you do, you actually use this one. So I'm going to give this one, if it's 175, and then maybe 25 meters. Okay. And create my mesh again. And you can clearly see that the fine region actually is now more. Okay. One question says, do they have ResIPy support for Apple Silicon on Mac OS? Yes. You have to do something to make it work. Okay. All right. Inversion. We will go back to the inversion settings later. All right, invert this data. Okay. The most important part for any geoelectric scientist, in my opinion, is to deal with the log of the inversion, not just the inversion itself. So this is telling you how the inversion is progressing. You want always to start from high root mean square inversion errors and get to low values. You want your inversion to be done in 3, 4, or 5 iterations. You don't want it to go like forever. And you don't definitely want this RMS to jump up. This happens. It's sometimes the inversion doesn't really work and it's just the RMS goes up. If any of these happen, then you have to go back and process your data better to solve that issue. But for this specific problem, everything went well. And when you go to the results, you clearly see the inverted plot. And there are several features you can identify in here. But that is not what we're going to talk about here. We're going to talk about the software capabilities. So in the results, you have the drop-down menu to select which file you want to see. So you imported one file, so you just see that one. You have the ability to select different parameters to be shown. You can show the resistivity in log format, log 10 format, or just the absolute resistivity. Log is always better because it shows you the features. It will remove the effect of really high or really low resistivities on your plot. It basically creates everything into a log format and better to distinguish. If I put it on non-log format, you see those features in here that were really visible in the log format are not really visible anymore. And then you can look at the sensitivity. Obviously, the farther you get from the electrodes, the sensitivity reduces. And you can also look at the conductivity, which is the inverse of resistivity. But if you have anything that is not in here, let's say you have an equation, empirical equation to calculate the water content from resistivity, and you want to plot that. How do you do that? You can calculate that in the compute attribute for yourself. So I am going to create something simple in here for now, but you can create as sophisticated as you like for your own attribute. All right. One really important thing is that you have to exactly follow the example that is in here. It is telling you you always need an X before brackets and into brackets a string of what you're trying to do, okay? And it should exactly follow one of these that is represented in here. It can't be anything outside of these. All right, so I want to calculate the conductivity, okay, in Siemens per meter instead of millisiemens per meter, okay? So I will use the actual resistivity to do that. That would be 1 over, I always put X, brackets open, resistivity, parentheses open, meter, I think it was lowercase o, this and that, just to make sure. Yes, that's correct. And then I will name it conductivity, Siemens per meter. And then I will compute that. And if it's successful, if it says conductivity computation successful, and you go back here and you now have the conductivity in Siemens per meter. Obviously, it's lower than the something to shown in here, so it's all showing 0, but that's a small issue that we're trying to solve for the next release. Anyway, so that was how you actually compute an extra attribute based on what we already have in there. Okay, what else do we have here? You can define a maximum and minimum. So let's say I go to the resistivity value and I just want to show a certain values. I clearly see I don't see anything like in 4,000 range or something. So I define the maximum to be shown as about 1,500. Apply. I now clearly see some features better. You can use this checkbox that says DOI estimate, that is depth of investigation estimation. This is based on the sensitivity, and it's basically a value of 0.001 multiplied by the maximum sensitivity that we have. So if I click on that, it will give me a certain depth of investigation estimation. And this is basically telling me that below this dashed line, I can't be really sure about the data, the results that I'm seeing, because we don't have enough sensitivity to that certain anomaly that we're seeing. You can select one of these color maps, depending on whatever you like. But if you don't see the color map that you like in here, you always can use the color maps that are supplied with Python, which is tremendous number of color maps. So you click on this icon again, select this one that says distance over elevation, not the one that says color bar. Okay, and then you go to images, etc. And then the color map in here, you now have so many, whatever you like. Just click on it and apply. And then you have that color map for yourself. I will show this again. That is a color map good for people who are colorblind. That is why we chose this as default. You can contour this if you like, and by default you see 14 contours. basically 2 per each of the shown values on your color bar. You can crop the corners of this. If most of the time is the corners, you can trust the data in that region, you can crop that. You can change the sensitivity overlay, how you want to show that. Basically, you can kind of fade away the area that is you have high uncertainty. This is kind of visualization only. And then this equal actually tells you that the X and Y axis are in equal scale. If you uncheck that, it actually just doesn't follow that. Okay, so if you look here now, my distance is a bit like cropped badly. You can click on this one that has settings and select tight layout. And now it brings everything back into the view correctly, okay? Again, you want to save the figure, you click on this, it will save the whole thing, the whole white thing in here, not just the plot. Or you can save the data, meaning that you forgot to select a working directory initially. Now you want to save your data. You can click on this and it will save the data for you. I'm going to desktop again into the inversion and click save the data and select that folder and it will save all the data. But if you want to give this inversion and all you did in here to your friend, or you want to basically come back in the future and look at it and don't want to go all the way from start, import, invert, and blah blah, you can actually save the project. So you save the project. This is now a format that anyone to the save project, I'm calling it. This is now a format that anytime that someone opens ResIPy can simply load it, and it will go all the way to the last step that you took when you were doing whatever with ResIPy. It is, for me, I mostly use it to just send something to someone that they just open it with ResIPy, take a look at it, and work with it. All right, what is next? Post-processing. What is post-processing? So with any inversion comes inversion errors. To basically solve those inversion errors, you always have to look at the errors that you will get. We want always with this inversion algorithm for the normalized error to be between -3 to +3. Sometimes it doesn't happen. It depends on the error models that you choose and so on, so many things. If that inversion error is not within the bounds that it should be, or it's showing like 1 point in whole pseudo section of error that is far outside of the normal area, basically an outlier, you can just click on it and then remove that one and then go back, click on apply filter and go back and re-invert your data. You basically remove that point that had a very high inversion error. Okay, so in this one, everything was fine, so I'm not going to do that. You can also basically use the error ranges to do that. And if you just, I don't know, deleted too many points and realize that's too much, you can just reset it and that point will be back again. Okay, time to look at some of the questions. What is the difference between the DOI and the sensitivity overlay? The DOI is just basically, the DOI estimate is only 0.001 multiplied by the max sensitivity. So it's just a contour that's showing that certain sensitivity in the data. The sensitivity overlay is basically the whole sensitivity. So if I set it to the maximum, it is starting from the cells that have the lowest opacity, the clear one, highest sensitivity, and the cells with the highest lowest opacity are the cells with lowest sensitivity. That's the difference between sensitivity overlay. And then we basically made this overlay slider that allows you to just define a maximum opacity to be shown at certain depths. I don't know how to put it, like, yeah, so instead of always having this sensitivity overlay, which is exactly this in here, but instead of in color scale, it is in different levels of opacity overlay. The DOI estimate is just a certain sensitivity level. What VH ratio is used for the coral crops? I don't know off the top of my head that question, but I think it's if we have a flat one, it is basically depth that is shown on the mesh on the vertical and horizontal. So 101, but if it's not like that, then it's slightly different. So if it's a topography, you can see there's like a difference between here and here. Export results for visualization in other plotting. We're going to talk about that. We're going to talk about that later. Export results to grid in Surfer. Yes, you can do that to grid in Surfer. I will have to stop sharing this one again and go back to let's stop share and share my screen entirely. And okay, where is the folder I made? So this is the 2D inversion folder. Initially I had here, right? So if I go inside there, in the inversion directory or the save data that you did, if you go to the working directory, there is a file that called f001_res.dat. You can use this to basically plot your data in Surfer. I'm not going to go over that. You can read what each column in that file, f001.resistivity.dat, means if you go in if you follow the instructions in the R2 README file. Okay. Can this do 1D inversion? No, it cannot do 1D inversion. When you have completed your inversion, can you export the data as an ASCII? Yes, that was the same thing I was showing. So the ASCII one is .f001_res.dat. Can you show the attribute tab again? Okay, we're going to do that. My DOI line is plotting way below the results. Yes, that can happen. How? If your fine coarse boundary depth is too shallow. By default, as I said, ResIPy finds something that assumes is good, but it might be just completely wrong. So you have to select the right fine coarse boundary depth. And if it's too shallow, then your DOI actually is below what is shown. The data is calculated, but it's just not shown. So always is good to know where this depth should be, the maximum depth of the data to be shown. Do we always need the Z elevation to conduct the inversion? No, if you're on a flat surface, you don't need Z. How can I get or download the software? Okay, that's a question for the beginning of the program. So The link should be in the chat.
I'll say I can answer that one, just then type out the answer for them.
Okay. I'm working on my resistivity code, but sometimes it doesn't recover the model depth correctly. Can you comment on this? I need a little bit more detail on that. What do you mean it doesn't recover the model depth correctly? For 3D surveys, we're going to talk about 3D surveys later. Yes, it can handle borehole IP and stuff. We're going to talk about 3D later. Okay, so we're running out of time. Let's go back to share screen. Just ResIPy again. Hopefully this time it's not gonna. Okay, it's working. All right, so I am going to do a 3D survey. You can restart your project in the options tab. I always say this is a good thing to do because sometimes it might not, something is left there that you want to get rid of it. All right, so now we want to do a 2D with 2D inversion and talk about some error modeling. For that, you need a certain data type that has a reciprocal measurement. So a reciprocal measurement is that basically you swap the potential and the current electrodes. In theory, it should not change the resistance value that you're measuring. The absolute value should not be changed. But the polarity is changed because you're now just changing the potential and electrode, current electrode locations. But the value should be the same. But obviously, it's not the case. There's always some small errors. So we do that. We do this reciprocal measurement to make sure that some certain measurements are good or no, or do we have to remove them? So we always do that, but a lot of people don't do that. But because we do it, we're gonna talk about it. So I'm gonna select one of the file types that in the examples that have that has this reciprocal measurement. That's a syscal file. So I restarted my project and I will select a new folder for my project. So 2D in recip, let's say, select that. And then syscal, and then import data. Now I go back to examples, EC2D, the syscal.csv file. Okay, so it's not showing anything because by default these two have not been cleared. So I'm going to clear them out. And now you're seeing something. Okay, so this is the time that the pre-processing is really helpful for you. If you go to the pre-processing tab, if you have reciprocal error, basically data set in your data, you can do a lot of error analysis with it. The first thing is that a pseudo section of basically the transfer resistance value. This might not show you anything, but if one data point again is an outlier, you can clearly click on it and click on the apply filter and remove it, and it will remove it for you. You can reset it back again, it will come back. But the most important thing is the histogram of error that tells you the distribution of error. We always want to have a Gaussian error distribution, like a bell-shaped error distribution, and everything around zero. If it's not like that, then our data is not good, probably. But if we have some outliers in this distribution, or basically looking at this distribution, we can decide at what percentage of error we can filter our data. In here, well, this is kind of a clean data, but I would say maybe at 2.5, I can get rid of this little notch in here, a few data points. So I am going to select reciprocal error here from the drop-down menu and click on 2.5% and then apply filter. Now that part is gone. I can go back to the section. I clearly see a bunch of points are removed. Okay, I'm gonna reset this just to show you what points were removed. That was this one, just individually. So you could have just clicked on it and remove it, or you could have just simply used the histogram of error. It's up to you. Sometimes you have the stacking error or deviation in certain file types. You can remove that too. So I can clearly see that there is one stacking error in here that I can click on it and remove it. Or you can use a percentage for removing those. And also then after you clear your data, you clean it up and basically now it's good. You can actually save your data. And in here, you can save it in res2din format or E4D format or just some CSV file for later use. We did that because both res2din and E4D don't allow you for data cleaning that much. So you can, if you don't like to use the inversion algorithm with ResIPy, you can just save it after this and import it in your own software. Okay, so go back to the reciprocal 2.5. I filter and okay. All right, so another tab that is open in here is resistance error model. This is where you can select an error model based on the observation of the error that you have. So we're plotting the average resistance between reciprocal pairs. So the normal and reciprocal, we just make an average of the resistance value and also the error between them. So you can clearly see there is in this log-log plot, there is a power law relationship between these two. So I can select the power law in here. And there is a very good correlation coefficient for this certain error model. What it does, it basically give the data with higher error values, lower weight in the inversion. So it allows you for just the influence of those high error data will be less on your inversion, final inversion. And then you can go to the inversion and invert your data. Notice that I forgot to create a mesh, right? No worries, it does it for me because it just basically by default reads it through here. And certain things, as I said, it's always good to fully restart the software, is that, for instance, it did not clear out the fine coarse boundary. And now you can see I'm left with like a weird mesh. So I'm gonna clear this out, create a mesh, and also make it a little finer. You don't need this kind of a thing, okay? And then do the inversion. Okay, so this one now is an inversion. Again, same possibilities you can do the DOI estimate in here. Again, it is not really perfect because it's based on sensitivity, and it tells you the depth of investigation that we have. Okay, so let's say that you don't want to do the error model in here and you don't have reciprocal measurements. How do you deal with the errors? Let's say I select this as observed error, so just not have an error model. You can actually select inversion errors in the inversion settings, okay? That would be the A weight and the B weight value for you. For more details, again, rather than reading just this, you can read the manuals in the help tab. But this is practically telling you the offset error between your data, that's the A weight, and the absolute error, percentage error in your data. So this 0.02 means 2% error, and is this one offset error is 0.01 ohmmeter error between your data. What are the rest? If you want to know more, you can just click on these links, and then there is a small explanation of what each means of these inversion settings in here. again, we don't have enough time to go over every detail, but value for tolerance is the final RMS value that the code tries to get to. The maximum number of iterations is that if the code doesn't reach to this value of tolerance before 10 iterations, it will stop at 10 iterations. You can change that, increase it. It's not a good practice, in my opinion, to have more than 4 or 5 iterations. Maximum apparent resistivity and minimum apparent resistivity. This is like a next filtering process that you can use, but we always set it as really high and really low because we already have a pre-processing to do that for us. And then in advanced tab, you have a bunch of other stuff, such as parallel inversion, which we're going to go over when we do a multi-file input. You can compute the modeling error. You can not crop the output, meaning that if I zoom out in here, now this mesh is cropped. If I go to inversion settings and say do not crop the output, it will not crop this side and this side of the mesh. So if I invert this and zoom out, you can see you will see the boundaries outside of the interest region, right? This is the Newman boundary, or the boundary of the mesh that we do the data analysis to have like a 3D current flow in the subsurface, but we don't show it basically. If you do not crop below mesh fine region, that will actually show you below this region as well. This is the area below this fine coarse boundary. So if I do the inversion again, now zoom out and zoom in, you can clearly see that's, I don't know how to show it, it's slightly hard. Oh, back. Zoom out. And see that it's showing you all the way to infinity, as low as it can go. So you always have this kind of a mesh. It is there, but we're just not showing it because we want to have a current flowing like without any boundaries, like it's going through the subsurface every direction. You can also use the model DOI. This is different than the DOI estimate. So the DOI estimate is based on the sensitivity. The model DOI, on the other hand, is based on the paper written by Olderming and Lee in 1999. And that is basically doing 3 inversions and 2 constrained inversions and 1 unconstrained inversions. And compare that to calculate the depth of investigation. This is a more accurate way to calculate the depth of investigation. So I am going to do that, but for that, I'm going to make it fast. I'm going to create a coarse mesh and invert that. So this is now telling you the depth of investigation based on that approach, okay? If you kind of notice, it's kind of similar to the previous one with the sensitivity. So most of the times you don't need to do this, but you have the option to do that. Okay, let's go back to the questions and answers. Can the inversion results be displayed in OSIS montage? I don't think so. If I carry out a workflow in the GUI, can I export the equivalent comments to rerun with the API? Absolutely. So when you go to the options, you can select save API log, and it will basically tell you what codes we did to get to this. So if you do that, and you will, let's say, save it again, I will save it on my desktop and name it something API log and save. And again, I have to stop sharing and share my screen. and then I will show you the API log. So this is the API log. This is crazy because I did a lot of changes, but you can clearly see, you can have it starts from importing your project and selecting the data directory, creating a survey from a certain file, and so on. So you have all of that in coding format. So if you take that and use it, it might be not really visible. I don't know, how do I make it bigger? No. Yeah, you have that. I think you get the idea. What is the next question? What if you don't have a full set of reciprocals? It really doesn't matter. We will make the error model and the reciprocal error based on whatever reciprocal that you have. Just don't do remove unpaired, because then those that they don't have a reciprocal pair will be removed. Okay, so this remove unpaired is only there to remove the unwanted instrument added points to your data. Can we check measure self potential and potential values before removing it? No, unfortunately, you can't do any self potential with ResIPy. Yes, will the program remove all the data points without a reciprocal? Yes. What is the equation for calculate reciprocal error in ResIPy? In context of surveys in salt water where resistive values are less than 1, sometimes this error is huge just because we are dividing by number less than 1. I don't follow the question. For more information about the resistance reciprocal error calculation, you can reach out to me later, and then I will send you a couple of papers that they talk about this. Which example data are you using for reciprocal? Or yeah, that was Syscal 2D. So if you go to the examples again, the DC2D, Syscal CSV, that's it. Can you calculate individual errors for future data collection? Yes, if you save your data when you do the pre-processing in CSV format, you will have columns that tell you about the individual error. Can we change the color of the legend bar? Yes, you can. Use the model DOI option with the Olderman and Lee method. Do we need a specific inversion settings? No. Can we potentially create a wrong DOI model by mistake? That's a good point. It's up to you to trust the DOI or not. It's up to you because that's basically, again, you have to read the paper, Olderman and Lee paper, and see what they did. But their approach is really conservative, in my opinion. And sometimes it gives you a really, really shallow DOI, particularly if you have a very conductive layer at the surface. Let's say you have a clay layer at the surface, 1 meter, and then you get a really shallow DOI, and what you probably are able to see below that. So it's up to you. Okay, let's move on. Okay, while we're waiting for that, there are some other questions. Does this provide an option to process time-lapse resistivity data? Yes, we can do that. Can we put collate many 2D profiles into 3D model? Yes, you can. Okay. Let's go back. Share screen again. All right, so I'm going to show a quick induced polarization data and how you do the error analysis in there. So for that, again, I'm selecting the Syscal and import data. And then if you go there, in there, it's a IP2D folder and another Syscal one. Just select that. Now, by default, because this data contains induced polarization, this induced polarization is checked and showing you a pseudo-section of phase shift for you based on the value of chargeability you have. Automatically converts it into phase shift if it knows the instrument. For instance, for Syscal, it multiplied the chargeability by 1.2. But if it doesn't know that, it's just the same value of chargeability, but just says it's phase shift. So bear that in mind. If you want to change that, because there's a linear relationship between chargeability and phase shift at most low frequency measurements, you can go to the pre-processing, the phase filtering tab, and then change the conversion factor for yourself. Okay, whatever that is, you can kind of calculate that in the lab. But if your data contains IP and you don't want to do IP, you just want a resistivity, you just uncheck this and you deal with it just a regular resistivity. All right, so with IP, the phase filtering tab is now open in there, and you have a bunch of other filtering capabilities. One of them is range filtering, meaning that you look at the range of the plotted data, you can delete that. And also you have also the previous filterings available, all that. If it's there in your data with resistivity, you have that capability of filtering. You have something called the DCA filtering, decay curve analysis, that's only for Syscal files and for certain export types, so I'm not going to go over that. And you can remove the nested measurements, meaning that the potential electrodes are in between the current electrodes. Like if you do that, Wenner, Schlumberger, and such arrays will be removed. So be aware of that. But why we do have this is sometimes we have one potential electrode nested in between two for some weird reason, and that causes a significant unwanted polarization, and we can remove that. This remove reciprocal part is only a visualization, so it just tells you how this works. And essentially, we're showing a plot of first pair of current electrode versus first pair of potential electrodes and their phase values. It's based on a paper that, again, I can provide you with after this to show how this basically affects how we can use this to kind of look at our data. I can clearly see here, why do we do that? I can clearly see here this certain potential electrode measurement, just one, is showing a really relatively high phase value compared to the rest of the measurements. So I can clearly know that this one is just noise. It's impossible to have one electrode showing high values. So that's the benefit of having this this kind of heat map kind of graph. Okay, then you have the phase error model. It's similar to the resistance error model. There's another equation for that, but you have power law and parabola, basically second degree of power. And you apply that, again, look at the error model. If it's a good fit, you can use it. Sometimes just a fit is not the right thing. So this looks like a good fit, but for phase, we always want it to be a negative power law. So basically from higher values to lower values, this is going from low values to high values for the phase shift, which is not a good thing. So I'm not going to use that for my error analysis. All right, so we go to the mesh, again, create a mesh and inversion setting, and everything looks good. We do the inversion. So in addition to the previous things that you had when you do the resistivity, now you have a lot of more that relate to IP, such as the phase map, the real and imaginary conductivity of the complex conductivity, the chargeability, and the magnitude, which is the resistivity values. And the rest is pretty much the same. So if, again, you have a attribute that you want to compute, you can either use one of these to create a new attribute, or you can actually combine these. It's up to you. If you want to show something that use both phase and resistivity values to, I don't know, a Pelton model, let's say, or something like that, you can use that. You can calculate that. And yeah, so that was a quick IP thing. The most important thing for me is just the filtering process that you have to take into account. Okay, let's start project. We want to do a cross-borehole measurements right now, cross-borehole. So I am going to use one of the examples that is in protocol format now. So selecting protocol DC, import data, going to examples, 2D borehole, and then select the protocol .dat. So here's a question. When I do that, you don't see where I select the data, right? Or do you?
You mean like your file explorer?
Yeah, do you see that?
Yeah.
Okay, that's good. That's good. I thought it's just showing the software, so that's good. Okay. All right, examples, sorry. DC2D borehole protocol .dat. All right, examples DC2D borehole. Okay. Obviously, this makes no sense. There is no such section for cross borehole measurement. The cross borehole measurement has two arrays in two boreholes, and then there's no. It's just for survey for surface measurements. This kind of section. So I'm going to click on the unconventional survey, just to not see that weird thing. And most important thing for cross borehole is that you define the right electrode format. Okay. So how do I do that? Now it's the time that you need the right XYZ in here. So I am going to show you how that file should look like. Let me open that. All right, so when you want to import any electrode topography, you can easily populate these manually. So writing something, right? It works. Or you have your own Excel file or anything. You can just copy the column that you want to copy to as your Z. So I'm going to select the whole Z values in here and Control C or Command C for copying, and click on the first one in here and just paste it. It'll automatically paste everything for me. Okay. Now, these are borehole measurements, meaning the electrodes are buried into the ground. You have to select them. Either you can select the whole, everything to be buried by clicking on the buried label in here, okay? And then uncheck whatever that is not buried. So there are several electrodes that may be at the surface. They have a zero topography, right? So those are unburied electrodes. I am going to select those as being not buried. Okay. Or instead of doing all this crazy thing that I just did, you can create an Excel file, a CSV file, not an Excel file, a CSV file that has an X, Y, Z column for the coordinates of the electrodes, right? And a column that called buried, if you use 1 as being buried, or 0 as being not buried, meaning that's a surface electrode. All right, so I am going to share back my ResIPy so you can see it better. Okay, in here, you click on import CSV file with headers, and in the same DC2D borehole, you click on the elec.csv and open. If by default you follow the format that I said, I'm just gonna click on generate so it doesn't get populated at all. If you import that format for your CSV file, when you open it, it automatically populates everything for you. So those that are buried will be checked as buried. The Z values will be populated, X values will be populated, everything will be populated. And when we go to the mesh tab, we create a mesh, and now you have a cross borehole measurement. So if you see the the black ones in here are your electrodes, starting from the surface all the way down to 0. You, if an electrode, one important thing is that for buried electrodes, your depth should be negative. I think, I'm not sure, but if you're dealing with elevations in here, that might cause some error. So give it a try yourself. But I think we don't account for true elevation for Z when we're dealing with cross-borehole. We're dealing with relative elevation. So surface is 0 and everything underneath that is negative. All right, mesh and then inversion and invert this data, similar like before. And you get the inverted data. So this is a cross-borehole. What I really wanted to say that is important is to always look at the electrode topography tab and make sure that it makes sense before doing the inversion. Start. So pole-dipole, pole-pole, do we support that? Yes, we do. So I'm going to use again a res2dn file with the pole-dipole format, and go to import to examples to parser and res2dn pole-dipole. Open. It's no longer an unconventional, it's a regular survey. So how do we deal with the pole-dipole stuff? How do we define an electrode as a pole or a dipole, or we have two of them? When an electrode is basically an infinity, you can put negative 9999 or positive 99999 for it as being pole, one of the remote electrodes. It doesn't matter if you put negative or positive, but so if I go back, it's just show it different, but it essentially in the inversion, it doesn't matter. So why negative, why positive? If you're dealing with a pole-pole, so I'm importing the pole-pole one, then that's how you actually distinguish between the two remote electrodes. One of them is the positive, one of them is negative now. I think if you put anything from 4 nines all the way to 6 nines, you should be good. So hopefully you don't have any electrodes exactly at 9999 in your actual survey, because that's the flag that we were using. And you only need to put that in the X value. Even in the 3D, you don't need to turn the Y or Z, but that's just a flag for knowing it's a pole-dipole or a pole-pole. And then when I create the mesh, it just basically assumes that the electrode is in infinity. The mesh is there, the electrode is on the mesh, but it's just not visualized for showing. Again, if I show the whole mesh, essentially at the end, you will see that it's there. Okay. Don't want to invert that, obviously. So I'm going to restart project data. Custom parser. This is where when you have a file that does not follow anything that is supported with ResIPy. So I'm going to just to show you how it works, I'm just going to go to the DC2D and select the Syscal one. I know we have something for that, but just in case some file doesn't have it. So what do you need? You need a location for current electrode 1, your A or C1 in the file. You can select a certain delimiter. You may have like a different type of delimiter. Just define it in here if it's not default comma. If you have a bunch of headers, you can remove them. So you look at the file itself and then say, okay, how many lines I have to skip? Then you skip those to get to the data. And then you may have something at the end of the file. You can remove them by saying just read the lines up the way to a certain line number. And then it will read them like this, hopefully. We'll have some headers and some data. So my column, current A is SP1, current B is SP2, M is SP3, N is SP4. If you have potential or current input, you can put it. If you don't have that and you have resistance, you can select the transfer resistance. You have chargeability, you can add it, and so on. So in here, I have the potential, so I'm going to put the VP input current. We have stacking error as dev, and so on, whatever. These are enough. And then you can import a data set, and it will import it for you. And it really doesn't matter to be one of the file formats that we have over there, okay? All right, so that's the start project. Let's do some 3D stuff while we have time. So I will do a simple 3D protocol format. So I'm going to select 3D, inverse, protocol DC, import data, examples, DC 3D, protocol, open. Oh, it looks not like 3D, right? Well, that's because we haven't imported any electrodes. By default, we don't know if your file is 3D. For certain types of files, such as 3D general format or Res2D, Resin or Syscal or Aries or E4D, we will know that, or BERT, we will know that. But some files don't have it, so you have to import, you have to always check for the electrodes. I'm gonna import the electrodes from the file. So it all automatically populated the X, Y, and Z for us. So it's a flat surface, no Z, but there is a Y column now. If I go back now, I'm seeing the pseudo section of my survey in 3D. The pre-processing now does not have a pseudo section. We cannot click on a 3D pseudo section, but if you have reciprocal data, you can see the error model and delete based on that. And you can also select on the resistance error model, check it if you have it or not. All right, so mesh. In here, now the mesh options are different than before. You have the half space, tank, cylinder, and even you can import your custom mesh. If you're dealing with surface resistivity, you always want to select the half space meshes. Click on a create mesh. You have a 3D mesh like that. Again, fine mesh boundary course defines how deep you can see. Let's say make this 10 meters. Characteristic length, the same thing, but just 3D. So the length of the smallest of the cells that you have. Growth factor from depth, meaning that the part that you don't see actually, how big it gets from the largest one at the bottom. Growth factor from surface means that how you grow inside the mesh that you can see. Okay, so if I make this one 1, so there's basically no growth factor. Didn't work that well. Maybe I should have, I don't know, 2. Okay, maybe we have a problem. What? Looks like we have a bug. I have to call Jimmy. Shouldn't have shown anything. Anyway, ideally it shouldn't be like that. Okay, I will do the inversion for this, and you will see a 3D plot of that. You can kind of contour it with Delaunay format. You can slice it, define a threshold to be shown. Or let's say I want to slice it, so I click on the grid so I know what grid I'm dealing with, and I will slice it at x equal to -4, actually x equal to 10, and then also at 30, and also at 45, and then also at y equal to 0, and maybe at z equal to -6. Right? You don't have to do that. Oh, let's leave that. And then you have a slice your mesh. You can slice it along the electrodes if you have a certain survey that the electrodes are following a correct order, or if it's like a, I don't know, a boat survey or a toad survey or something like that. Okay. Let's see, what are the questions? When saving a mesh for 3D case without topography in ResIPy and then opening a geofile, a text editor, and topography point Z coordinate are missing. The Z coordinate is always 0. Is it possible to export a full mesh with Z coordinates? The geofile is not a mesh file. The geofile is actually, I don't think we can actually export in geo. Can we? Yeah, that's the problem. So for exporting a mesh, you have the option of exporting in VTK, in .mesh, MSH, or .dat file. So you can export in geofile. Can we add GPS coordinates on the 3D model? Yes, if they are in UTM format, which is a meter format. Yes, you can do that. 3D growth factor worked fine on my side. Good for you. Can I open a GeoSoft voxel here? No, I don't think so. Okay, I think we're out of time.
Believe so. All right,
I
well,
have more to go over, but that's fine. Yes. Yes.
Last minute quote. Oh, go ahead.
Unfortunately, I'm sorry that the time wasn't there. But we have a lot more in our YouTube channel, so I highly recommend that you visit our YouTube channel. I'm gonna share my screen again. So YouTube, right? If you go to our GitLab site and then go to our YouTube channel, then we have a lot of tutorial videos there, and I highly recommend that you take a look at those for 3D forward modeling, 2D forward modeling, and a lot more. And always don't hesitate to ask any of us any questions in the issues tab of GitLab or even on YouTube or anything like that. Another question, how do you change the VH smoothness ratio for e.g. give preference to horizontal? Yes, yes, you could do that. It's in the inversion settings tab, in the advanced tab inside that, and there is an alpha and aniso or alpha anisotropy scale that you can select and change that. I closed the ResIPy, but I can open it again and show you. And then if you give it a value of more than 1, you're basically preferring the horizontal structure. If you give it a value between 0 and 1, you're preferring your preferences is vertical features. So just a quick thing. I'm opening that, and if you go to inversion setting, advanced value for alpha and iso by default is 1. Can I send mail for any issues? No, please don't do that, because then sometimes I don't know how to solve an issue. Might be an issue with something that my colleague have written the code for, so that would be hard for me to solve it. So if you submit an issue on GitLab, then the right person will get to you. This is open source, or this is open source, no subscription.
Yeah, I think we're just gonna have to end there because we're a few minutes over. Thank you again, everyone, for coming to and attending this webinar. Thank you, Senna, for taking the time to run through just a number of the things that ResIPy can do. I know there's so much more you would have liked to be able to show, but if only we had the time. Let's see. There's gonna be a follow-up email from SEG to everyone who's registered. Please respond to that with any comments on stuff that you enjoyed, stuff that could have been done better, suggestions for future topics of open source software that you would like us to look into. And yeah, please keep an eye on your email and for social media for any of our follow-up webinars, either for the open source series that we're doing or for the critical skills series that we are also working on. There's a webinar next month about I need to remind myself what it is. How to negotiate kind of your first job position. So keep an eye out for that. Thank you again, everyone. And yeah, I'll enjoy the rest of your days.
Thank you.